Hi, my name is Derek Garcia, and today I'll be covering JBOM, a jar executable capable of generating CycloneDX SBOMs for Java binaries and running processes on local or target systems. This tool is the first of its kind that we've reviewed that can generate SBOMs without access to the source code, which could prove invaluable while attempting to make sure not only your own code is secure, but other environments that you may be interacting with. Today I'll be demonstrating on an Ubuntu server. So to install the tool, just download the latest binary release from the JBOM repo. So in my case, I'm going to use wget and rename the file for convenience and make it executable. So wget and just moving it to a new file name and making it executable. And you can see jbom.jar is successfully there. And we can check to see that it worked by just passing some random value. And there we go. To start, I'll be demonstrating the local capabilities of JBOM. JBOM can generate a static SBOM from a nested jar, or, EAR, and zip files using the -f flag and the given path. I've compiled a jar file from a demo project and moved it into this directory, which was that demo.jar that you saw earlier. So the command will look like this, using the JBOM jar file and passing in my target jar. And we can view the results. And it's a fairly in-depth SBOM. By default, all the outputs will be put into the JBOM directory, which we can see was made, with the standard convention of jbom-jar file. So we'll see. You can see jbom-the name of the jar file, .json. To change the output directory, we can use the -o flag and the desired path. And in the case you have several jar files to scan or any sort of file, you can pass in the parent directory with the -d flag. So in this case, I'm just passing in this current directory and writing it out to the out directory. And we can see we have an SBOM. You should ideally use this with a project directory where the files are related, but I just use this one to show that it works. Scanning static jar binaries is already a valuable tool to have, but JBOM exceeds by generating SBOMs on running processes, allowing it to include runtime libraries that may have been excluded from static analysis. To demonstrate, I'm quickly going to start up a Java web app in another window, just so you can see what's happening server side. Alright, so I've set up my two terminals. One of them is acting as a client, the other as a server. So server side, I'm going to start my web app. Alright, now that that's up and running, all we need to do is just run JBOM without any arguments, and it'll automatically scan the system for any locally running processes. Alright, so a few things happened here. On the client side, we can see that a local Java is running with its unique PID. And the server side, we can see that JBOM had attached and generated an SBOM. So if we list that JBOM directory, we can see our JBOM with our PID is right here. And we can see our previously generated one from the static file. You can also notice that the runtime one is a little larger than the static one, which means it's a good indicator that these runtime libraries are being included for a more accurate SBOM. JBOM can potentially scan remote hosts as well, but unfortunately I cannot get this feature to work. I'll demonstrate how the feature should work from signing in with my current session. So we can scan for any processes on a remote host using the -h flag with the target host name. So in my case, I'm executing the jar file with -h and which is butneg for my host name. And running that, I can log in with my credentials. and we can see we successfully connected. Once again, a few things. We can see that we generated one remote SBOM, and we can see that on the server side that again we generated the exact same thing. This time we just know we are coming from a host name rather than a local process. So if I list out JBOM once again, we can see here's our host name and our static and process. We can see that the host name and the process are both the same size, which means they're including the same runtime libraries. Okay, for this last section, I've switched back just to the client view. So when connecting to the host, we can use the -u and -p flags, both of which are uppercase, can be used to pass in the target username and password respectively to help speed things up. We can also use the -d flag to scan remote repositories just like we demonstrated earlier. And same thing applies for the file. If you pass in the path to a target file, we can scan that as well. So I have my host name, my user that I'm logging in as, my directory, and the path to that directory. And I can log in. And there we go. We can see a bit confusing, but we have scanned in this JBOM directory, which is the current working one, and I can list that right now. And we can see our JBOM directory file right here. And that's it for JBOM. Even though the remote scanning needs work, the parsing of static and runtime jar files is extremely useful for generating the most accurate SBOMs. I'd highly recommend this tool as it's one of the few that we found that is capable of scanning without access to the source code. Thank you for watching. If you have any questions, comments, or concerns, please feel free to reach out to us at learnsbom.com.
Thank you for checking out this video. If you really liked it, be sure to check out our other videos right here, and then you can also subscribe right up top here. And again, thank you. Bye-bye.